I guess the main topic to practice this week is references. And I'm genuinely curious to know what kind of practice exercises ChatGPT generates if I just say, I want practice with references. Because usually we sort of test knowledge of references by giving tracing exercises. So I'm going to say, I'm learning C++ 20. I just learned about references. And I want some practice. I also, the only other things I already know about are, let's see, we know basic I/O, vectors, and strings. Can you generate 3 programming exercises involving references? What I'd like is at least one of these to involve starter code. So I'm going to say for the third exercise, can you generate some starter code, including test cases, but leave a few functions blank for me to implement? And then I'll say, don't show me the solution. Of course. Okay, so let's see what it comes up with. Exercise 1, swap function. Okay, yep, that's a pretty standard exercise. This is also a very standard like pointer exercise in C, so I guess it makes sense that we come up with this for references. Exercise 2, modify vector elements. Write a function add value to vector that adds a given value to each element of the vector. That's a good idea. Exercise 3, student grades management. So one thing I learned doing exercises for CSC 111 with ChatGPT is that ChatGPT is a lot more human than people think. So when I try to come up with practice exercises or like midterm questions or something, I run out of ideas and then, I don't know, I sort of write what I know. And it seems like ChatGPT does the same thing. I think it's because it's absorbed a lot of information from other instructors of programming courses. When I can't think of an idea for an exercise, I'm like, oh, what about students and grades? Because I mean, that's what I'm always thinking about. So, okay, you're tasked with creating a program to manage student grades. Below is the starter code with some functions to implement. So we've got a structure type here. This would be a great exercise to practice next week. So we'll see if it generates this exercise again. I don't want to deal with structure types in this video. I'm going to see if it can correct this to not use structure types. I suspect that if it does, it'll be a monstrosity, but I'm going to see if it'll do that. And if it won't, then I'll ask for a replacement. So I do want to cover the version that uses structure types in C++. I just don't want to do that this week. But we'll start using exercise 1. All right, exercise 1 is write a swap function. Write a function void swap ints that takes 2 integer references and swaps their values. So it actually gave me a function signature, so I'm going to just paste that in. I guess it's my responsibility to write some tests. So I'm going to call my 2 integers x and y. Actually, I'll make a z too. All right, and then I'm going to print them out. I guess I'll print them out a few times. So I'll say x equals, and then I'll print out x, and then y equals, and then I'll print out y, and then z equals, and then I'll print out z. And I'll just do this a few times so we can try playing with the swap function. So I'll write swap ints x, y. So I'm expecting at first I see 6, 10, and 17 for x, y, and z. And then when I swap x and y, it should be 10, 6, and 17. And then when I swap, let's swap x and z. Okay, so just to give you some idea of my thinking here x, y, and z, and then they're all int. All right, so if I write this correctly, and you know, this will be a pretty straightforward exercise. Probably you're staring at this, watching this, and probably already sort of can see what 3 lines of code I'm going to write in the function. Okay, so I swap, 6, 10, 17, I swap x and y, so I want 10, 6, 10, 6, and 17. I swap x and z, and I want 17, 6, and 10. All right, that's what I expect to see. So let's write the swap function. Now, the idea here, I'm actually going to make an editorial change just to illustrate this. The addition or removal of white space changes nothing, so I'm not really modifying the exercise by doing this. I like putting the ampersand as part of the type because, I mean, it is part of the type, but I like putting it over here to make it clear that this is that the type of B is reference to int. When the function begins, a and b are going to be values that come in from outside. So unlike a pointer in C, the value of a, when I use it just like a regular int, but it turns out that a doesn't live inside of the function swap ints, it lives somewhere else. The caller provided it to me. Okay, so which means if I want to swap two values, I'm pretty much going to swap them as if I were swapping the values in main, if I wanted to swap the values of x, y, and z in main. So what I'll do is make a temporary variable, so temp, and I'll set that to be a. Oh, wait a minute. I've written some C-style initializers here. I better get rid of those. So while it's valid, it's good to be consistent and always use uniform initialization. Okay, so I create a temp variable, I set that to a, I set a to equal b, I set b to equal my temp variable. And then, assuming I haven't misunderstood the exercise, that means we've got a nice, pleasant exercise to start us off for the day. All right, we run it. Okay, so 6, 10, 17, I swap x and y, I get 10, 6, 17. I swap x and z, I get 17, 6, 10. All right, there's the exercise. I'm done. That's exercise 1. We'll head on over and take a look at exercise 2. Write a function add value to vector that adds the given value to each element of the vector. Now, I seem to remember that I did write this in some other video, so maybe I should veto it. I think it's a quick enough one that I can just go do it again. All right, so I'll paste that into exercise 2 here. And it seems like it's given me a signature for this one as well, so I'll just put the signature down here. I'm going to need to include vector in my code. Okay, so it looks like what we're doing is we're being given a vector and then a value to add to it. I guess I'll write some testing code in main. I'm not going to test this very thoroughly because I believe I have done this exercise. By now, probably you've seen me do this exercise live in a lecture, but I don't know, for completeness, why don't we just do the exercise? Okay, so here's my vector v. I'm going to print out the elements of the vector, so I'll just write a quick loop to do that. I'm going to use the auto keyword. I didn't do that last week, but we know about that now. So I'm going to look at every single element in my vector v, and I'm going to print it out. And then I'll print out a new line. All right, so I'll just begin by doing that to make sure my code compiles. Yeah, that's fair. Okay, so I actually have to add some curly brackets for this function. Otherwise, it complains. That looks good. Okay, practice references 2. Okay, so it prints out my vectors 6, 10, 17. I'm going to copy and paste this loop, and in the meantime, I'm going to call my add value to vector function. I'm just going to hand it my vector v, and then I'm going to hand it, I don't know, let's try adding 100 to every element. Now, if I wanted to do more detailed testing, which, as I said, I won't because this is an exercise I've done before, then I probably would want to test out that I can add 0 and I can add negative 100, or I can call the function twice and add values to the vector more than once, and it still works. All right, so how do I add the value to the vector? Well, I've got a couple of options. There's one trap we can fall into here, and I'll show it off. So we have enough code now to see whether this is working. So it prints the vector twice, and I expect that 100 gets added to each element between the 2 times it gets printed. And you can see that's not currently happening because I haven't written anything yet. The trap we can fall into is using the wrong kind of for each loop. So I could write something like this. I could say, look at every element x in the vector, x plus equals value. And this should compile. It's just that it's not going to do anything. And the reason is because in a for each loop, if I write auto x in vec, what I'm saying is get every element out of the vector and make a copy of it and store it in a new local variable scoped into the loop called x. But that means x is a separate value. It's not the actual element in the vector, it's a copy. So if I modify it, nothing's going to happen to the elements of the vector. Okay, so one implementation of this would be simply to add a reference here. And that means that I'm saying now, for every actual element of the vector, so x isn't a copy of an element of the vector, x is the element of the vector, because I'm using a reference here. So we'll try that out. All right, so I'm adding 100. And so I could do that. Of course, I could also write int instead of auto, but as you've seen, once we start using the auto keyword, we just can't stop. And I could also, if you're asked to write something like this on an exam and you're not quite sure what to do with the for each loop, you could always fall back on a C style, on one of the old-fashioned indexing loops. So I could say unsigned int I starts at 0, I is less than vec.size, I++. And then I could just write vec dot at I plus equals value. So I could just modify the elements of the vector directly, working with them by index. Let's see. So the error there is because I forgot an opening curly bracket, I think. So we'll just try that out. Looks like that was the problem. Run it again, we can see that still works. So there are a few options for adding values to vectors, I like the for each loop one, and I think as time goes by, you're going to want to try and use that one more and more, because within a few weeks, we're going to be working with collections that aren't vectors, that still have elements we want to iterate over, but don't have a .at function. So getting used to for each loops is going to help us out later. But that's the end of exercise 2. Wow, okay, these are short exercises. So let's take a look at exercise 3. So I don't want to do the version that's suggested because we haven't seen this material yet. I mean, you all know what a structure is, but we're not ready. I'd rather not talk about structures in C++ today. So I'm going to try asking it to fix the exercise. I don't want to work with struct types today. Can you regenerate exercise 3 so that I do not need structures? So if it does this, like if it understands what I mean and tries to generate a new version of the same exercise, I wouldn't be surprised if it's ugly, because it does seem as if keeping things organized, using a structure type is a natural thing to do if you want to keep things organized for a purpose like this. I'm interested in seeing what it comes up with. Oh, and I didn't ask it not to show me the solution. Okay, this is sort of what I was expecting it to come up with, and it looks like it is going to be the full exercise, so we'll wait for it to finish. Feel free to work on this revised exercise 3. Well, I'm glad it gave me permission. So I'm going to copy this code. Maybe before I do, these function descriptions are very, I don't know, they're a little bit vague, and I have a feeling I might want to come back and ask a clarifying question if I go with just that. So I'm going to say, can you regenerate, I'll just say it looks good. That looks great. Can you regenerate the template with a formal header comment, or with a header comment before each function containing a formal specification? So I would like it if it was giving me a sort of, I don't know, midterm style specification for the function. And it looks like it figured out what I wanted. Okay, so I'm going to grab this code if it's finished. Okay, it's not finished yet. We'll wait for it. All right, so we're going to grab the code, and then we'll go over and take a look at the template. Okay, so I'm going to replace all of my code with a template. I'm going to save it. I'm going to try compiling the template from scratch. I wouldn't be surprised if it gives me some compiler warnings because of missing return values, but I just want to make sure there's no obvious, so find highest grade. All right, so it looks like we've got 2 functions to write. Now, the goal of the original exercise was to keep track of a set of student names and the associated grade. The way I would normally do this, and probably the way you would do it in CSC 111, and in this course, frankly, is you'd make a structure to represent a student, so a student object, and then each object contains a name and a grade. But I told it not to use structures. I told it, I don't want to use structures, give me something else. And it looks like what it came up with, this is pretty much the same thing I would do for this situation. What it came up with was, instead of having a vector of student objects where each object has a name and a grade, instead it has a vector of names and then a separate vector of grades. And the idea is, I assume, basically that the person whose name appears at index 7 of the names array goes with the grade that occurs at index 7 of the grades array. That's the idea. And that makes sense. That is a good way to solve this problem if you can't use structures for some reason. It doesn't say that explicitly, but that's how I'm going to interpret it. And I assume that the tests that it wrote me in main will give me some way of ascertaining whether I actually have done what it wants. So the first thing is I have this add student function that takes the vector of all the names and all the grades and a new name and grade to add to the vector. And that doesn't look too tough because, again, it seems like, let's see what names it generated. So it's got these, okay, so basically what I've got is this vector called names and this other vector called grades. We've got that, and then I've got Alice, Bob, and Charlie. Now, I appreciate that when it generated these apparently random names, it tried to go with A, B, C. I've observed in the past that when you ask ChatGPT for input data that involves demographic information, like people's names, it rather suspiciously likes to generate names from, let's just say, a certain part of the world. And one might inquire whether there's some systemic bias that plays into that. Okay, so Alice's grade is 85.5. Bob has 92.0. I'm going to add to my statement from a minute ago. That systemic bias I mentioned, of course, is not necessarily bias in the AI's algorithm. It's because of what the algorithm picked up. It's out there reading information off the internet, and how interesting that for some reason whatever information it's being told to read is biased towards a certain set of names. The actual mathematics underlying the algorithms might not themselves be biased. Okay, so anyway, here are my name and grade array. Basically, the idea is if I look at index 0, that would be Alice, and the grade is 85.5. Index 1 is Bob, and the grade is 92.0. Index 2 is Charlie, and the grade is 78.3. If I want to add a new student in grade, pretty much what I do is I just add the new student's name at the end of the names array and the grade at the end of the grades array. That's it. And the reason why I think it's still a useful exercise is we get to take a look at some interesting types that are going on. So when I call add student, I have to pass in these two vectors by reference because I want to modify the original, the master array of names and grades. And then when I pass in the new name of a student, what this is generated. So in this course, in an exercise like this on an exam, it probably would look like this, just to save you some trouble. But it's interesting that it generated this version that involves a const reference, because that is out in the wild, that probably is the way this would work. Strings could be very long, and if I pass one in without a reference, I'm making a copy of it. And why make a copy if I can avoid doing so? So passing something in by constant reference allows you to use the original, but not change the original. So you sort of get the best of both worlds. You don't make a copy, but you also don't run the risk of screwing up the original data. Now the grade is being passed in by value, because the grade is one numerical value. There's not really much advantage to passing that by reference. So all I think I have to do here is do names.pushback, and then I push back the new name that was given to me, and then grades.pushback of grade. All right. I'm wondering, okay, it's written the display students function for me. And this is interesting because this gives me an opportunity to read some code that ChatGPT wrote in C++. So it's taking the names and grades array as constant references. These are two vectors passed by constant reference because I don't want to make copies of them because I don't have to, but I don't want to modify them either, so I make them constant. But then it's doing this thing where it's using square brackets. Now, I do not approve of this. It turns out that in the context of this loop, the square brackets are legitimate. There's no case in this loop where the square brackets are going to cause us any trouble. But ChatGPT is not building all those good habits that I'm insistent that we all build and use .at all the time. If I wanted it to, it would do that. I could ask it to use .at. I could chastise it for using square brackets. Another interesting observation is this. The type of the loop index is size t, which is a more formal type that we could use instead of just the generic unsigned int that we usually use for loops. This is a little bit pedantic for it to, that is, in practice, it's not generally frowned upon to just use unsigned int. Additionally, I would probably just write auto here. I wouldn't even bother with worried about size t. And then it's using a C-style initializer, which is its right. I've also noticed in the last couple of videos, ChatGPT does not like stdendl. It would rather just use \n, which I think is a little bit risky. So \n works just fine for all of our purposes, but using endl is considered to be a better idea because it's more flexible and portable. But whatever, we'll just use the code ChatGPT gave us. So I'm going to run this again. This warning is because I haven't written that function yet. And that means if I call the find highest grade function, I'm going to get some weird random return value. And so when that happens, that's not a bug. It's just something I haven't gotten to yet. All right, so I call add student 3 times, and we can see that when I run display students, it does print out the names and grades of the students that were added. So that looks good. I think add student works. Then the highest grade, I think the highest grade's a little bit higher than that. That's basically 0, that number. So I'll now write find highest grade. So, okay, what's the idea here? So it takes the grades array and then finds the maximum element. All right, that's not so bad. But as usual, this happened in the last one of the last videos as well. What happens if there are no grades in the array? So if you give me an array with 0 grades in it, what do? How do I return the highest grade? ChatGPT might argue, hey, just return 0 or something. But 0 is a valid grade, unfortunately. Some of you might know that. And so I can't just return 0 if there are no grades in the array. What do? I'm going to ask it to explain itself. I'm working on the find highest grade function. What should I do if the grades array is empty? And I'm going to argue with it if it suggests what I just mentioned. We'll see, it's going to think. If the grades array is empty, you should handle the situation. Okay, it's going to show me the answer. You should handle the situation appropriately. Yeah, of course I should. That's why I asked. Since there are no grades to compare, you might want to return a special value or handle it in a way that makes sense. Yeah, right. That's what I'm asking. One common approach is to return a value that indicates there is no valid highest grade. For example, a negative value or the special not a number or nan symbol. Okay, a negative value would work here. 0 wouldn't, but a negative value would, because if we adopt the convention that grades can't be negative, then fair enough. I guess that wouldn't that wouldn't break anything. I was wondering whether it would suggest something that we haven't seen yet, so something called an exception, which we'll see next week, which is an orthodox way of getting out of a function when you find yourself in an impossible situation. But I'm going to do a negative value. So I'm going to say if the grades, I'm going to actually augment the specification. If the grades array is empty, return -1. Okay, so that gives me a pretty clear path. So if grades.size is equal to 0, well, then I just return -1. Otherwise, I'm going to loop over the grades array, and I'm going to pick out the maximum thing. So I'll just say, okay, so if I get to line 27, then I didn't return -1, which means there's at least one grade. So I'll say auto max is initialized to grades.at0. I'm just using auto here. And now I'm going to iterate over every element of my grades array. I'm going to use a for each loop. So for auto grade in grades. If the grade I'm looking at is larger than the maximum, then that'll become my new maximum. So if grade is greater than max, then max equals grade. Now, if you look at this for each loop, maybe you can observe that the for each loop does a little bit more work than I need. So I set max to be the first grade in the list, and then I iterate over all grades in the list, including the first grade in the list, which means I'm actually doing a little bit of work I don't need to do. You could stare at this and say, oh no, that's inefficient. And I could stare back at you and say, maybe, but not inefficient for me, the programmer. If the compiler notices this, it will optimize that away, so it'll get rid of that extra work. But if I wanted to get around that case, I would have to write the longer for loop. So that is, I'd have to spend more time typing. I'd write either an indexing loop or something else. I couldn't use a basic for each loop. And I like for each loops. I don't mind using a little bit of extra computation time in exchange for convenience. I'm aware that convenience has come at the cost of me now spending about 1.5 minutes explaining the convenience, which sort of cancels it out. But I still think this is a good technique. Okay, so I'm going to run this. And it says the maximum grade is 92. Okay, let's do a bit more testing here. Let's see what happens if we set the maximum grade to contain a fractional value. Okay, what happens if there's only one grade in the system? Okay, looks like it works. What happens if all the grades are the same? Okay, looks like that works as well. I think that's enough testing for this purpose. We know enough about the way that vectors work to be reasonably confident that this is a valid function. Oh, actually, wait a minute. Oh, that's interesting. Oh, I see. Okay, I must have pressed undo. Return max. So this wouldn't have compiled. For some reason, I was sitting in this state, which wouldn't have compiled. But because the code was working, I think what happened was I accidentally undid the code I already wrote. So what did compile correctly. I'm going to recompile and test it just one more time. Yeah, okay, so I think that's still working. I'm not sure what happened there. So in any event, I think this has been tested enough, given what we know about finding the maximum element of a vector. This is something we can rely upon pretty easily at this point. Okay, so I think we're done exercise 3. This was a pretty quick set of exercises. I'm going to ask for one more. mostly to make up for the fact that I feel like exercises 1 and 2 were relatively simple. So this, it looks like the modification it suggested to find highest grade was pretty much what I did, except it uses .empty instead of .size. Those 3 exercises were great. Can you generate another exercise with a similar format to exercise 3? That is, with starter code and some functions missing. And we'll see if I didn't say don't show me the solution. We'll see whether it does. It's thinking. Wow, it's running pretty slowly this morning. I sit here and wait for it, I guess. I'm not sure if I don't think this was a very confusing request. I'm inclined to sort of to fumble around and try do something to make it, maybe I'll hit stop and then I'll try it again. I don't know, maybe I really confused it. Okay, here we go. Write a program that swaps the values of 2 numbers. No, I already did that. Sorry. I already did a number swapping exercise. Try again. I feel like it should remember. I apologize for the repetition. Okay. It's going to make an exercise called, let's see, array manipulation. Write a program that takes an array. So when it says array, it clearly means vector because down in the code it's used vectors. I don't know if this is worth it because this looks a lot like what we've already done. So multiply every element by 2 or something. Sum up the array. No, that's too straightforward. That seems a bit too basic. Can you generate another one? Now, I guess I'm asking it for a challenge, so I suppose I shouldn't be... I can't... Yeah, I should prepare myself for it to give me something unreasonably challenging. I'll just ask it. I want a really challenging exercise involving references and starter code with functions missing. Just to remind you, I only know about basic I/O, because if I say challenging, it might generate something way off the rails. So basic I/O, vectors, strings, and references. Certainly, I understand your request. Well, we'll see. Matrix transpose, come on. No, not that one. Can you try again, please? It seems to have a pretty limited repertoire. Okay, advanced string manipulation. Okay, well, this is a little bit more promising. Write a program that takes a string as input and performs the following operations. Reverse the string in place using references. Remove all occurrences of a given character from the string using references. So it says using references to mean something that I'm not sure that I like. Just saying using references to me makes it sound mostly like I write a function and I can do whatever I want in the function, but I take my parameter by reference. Yeah, okay, that's fine. We can do this one. So let's copy this. We'll head back over. I'm just going to stick this on top of the code for exercise 2 because exercise 2 is something we did in the lectures otherwise. I'm not going to ask it for a formal specification for these because I think I know what it's asking me to do. I think it's pretty straightforward. So it's going to read a string from the user. There we go. It's going to create a reversed string, I guess, and then call this function. The idea behind this function seems to be that you give me a string and I have to perform the reversal operation. And when I'm done, the string you gave me is going to be reversed. Now, if this word in place weren't here, it would be perfectly valid to just make a new string, produce the reversal, and then set the old string to equal the new string. But it does specifically say in place. And I read the word in place to mean that I'm not allowed to create a copy of the string. So in place means I can just shuffle around the elements of the existing string. I can't make a copy. Maybe that's a self-imposed challenge. Now, remove character. Remove all occurrences of a character from a string. So you're giving me a string, you're giving me a character. I guess when I'm done, I'm going to modify this string to contain the same characters except any occurrence of character ch. It doesn't say I have to do this in place. So I'm going to do this function by making a new string that contains all of the characters that aren't equal to ch, and then copying that new string back into the old string. Okay, so I'm gonna run this to make sure that the template runs as provided, up to some maybe errors with return values. Okay, so we'll try running that. Practice references 2. Okay, hello world. All right, so it says, yeah, reverse string hello world, because there's no reversal happening. Let's remove the letter O, lowercase o, and we can see this also does nothing because we haven't written the code yet. Okay, implement this function. I want to reverse a string in place. Okay, so let's draw the characters of a string, and then here are the indices. So to reverse a string, if I'm allowed to make a copy, is pretty easy. We saw that last time, or we saw that in one of our earlier videos, the one on strings, because we can leverage the plus operator on strings, which makes life a lot easier for us. If I'm not allowed to make a copy, so I have to sort of shuffle around the indices of the string, then things are a little bit more challenging, and it becomes a lot more like a 111 string exercise. What I'm doing is swapping around indices. So here's the way I'm going to approach this. The reversal of the string will obviously be this. What I'm going to do is I'll observe, for example, that in the reversal, the first character and the last character trade places. The second character and the second to last character trade places. In this case, because the string has odd length, the character in the middle just stays where it is. So what I'm going to do is I'm going to start off an index at the beginning of the string, and I'm going to start off an index at the end of the string. And I'm going to run a loop. And after each iteration of the loop, the two indices are going to move closer together. So the one at the beginning will move to the right, the one at the end will move to the left. And then at each iteration, when I'm looking at these two indices, I'm going to, at the beginning of each iteration, swap the characters stored at each index. And then I'll move the indices. The left index goes forward, the right index goes backwards. And then I'll swap those characters, and then I'll move the left index forward, and the right index backward. And if the indices ever cross, so if the, we'll call this index the left index and this index the right index, if the left index ever ends up after the right index, then I'm done. Or if they ever end up pointing to the same thing. Okay, so I'm going to say int id. I'm actually going to call them index left and index right. For full disclosure, the reason why this solution came to me apparently so quickly is that I recorded a video where I asked ChatGPT for 111 string exercises about 3 or 4 days ago, and it suggested a very similar exercise. So I didn't just instantly invent this algorithm. I actually have written this algorithm in C a few days ago, so that's why it came to my mind so quickly. So my left index is 0. My right index, idxr, is going to be string.length -1, so the last valid index of the string. Now I'll do a while loop that says while index L is less than index R. Then what I'll do at each step is idx. Oh, I'm so much in C mode here that I'm writing C style initializations, so I'll get rid of that. And actually, now that I think about it, I'm also in C mode because I'm writing int instead of unsigned int. I'm using indices, so I should use unsigned int. In the interest of keeping things moving, I actually am going to keep in the C-style initializations. So C-style initializations are valid, but it's good to build the habit of always using uniform initialization, unless there's a reason not to. And here, strangely, there is a reason not to. The compiler is going to complain if I write this with a uniform initializer. So I'll just come back to that in a minute. Basically, at the end of each iteration, though, I'm going to add 1 to idxl. I'm going to subtract 1 from idxr. The indices are going to move closer together. In the meantime, I'm going to swap the characters positioned at each location. So I'm going to say auto C is set to str.at idxl, and then I will say, let's see, str.at idxl equals str.at idxr, and then str.at idxr equals C. Okay, so just a typical swapping, 3-line swap here. Okay, I'm going to run that. I think it should run fine even if I haven't written the second function. Okay, I'll do hello world. I'll just do hello to begin with, and that looks like it reversed, and then I'll remove the character C, I guess. Let's do hello world. It looks like that reversed correctly. Let's try doing, I'm going to enter the letter A and just make sure that I can reverse a 1-character string. Let's enter a string that has 3 characters just to try out at least one more length. Okay, that looks good. So it looks like it is reversing in pretty much every case. Let's do a little bit of cleanup here. So I want to use uniform initializers for this just because it's good to build that habit, and because that thing I just said of, oh, this is going to cause some trouble, that's I don't know, a bit of a cop-out. I should explain what I mean by that. So if I try and write this with uniform initializers, it's going to give me a warning that says narrowing conversion. And this is legalese. This is something that, to be honest, we don't need to worry about in this context for a bunch of different reasons, but it's a valid warning. So the type of str.length is not unsigned int. It's something else. And the compiler is pointing out that the type in this case happens to be long unsigned int. So the type of this expression, long unsigned int -1, is going to be long unsigned int. And as we know, in C++, when you use uniform initialization, it doesn't let you change types. Whatever you put in the curly brackets is supposed to be the same type as what you're creating. So what it's saying here is you should be making this variable of type long unsigned int, because that's the real type of the size of the string. Whoops, and so if I compile, you can see now the warning is gone. But this is weird. I don't know whether this is the kind of fix that I should be making, really. Like, I don't know that it makes my life any easier. Instead, what I probably should be doing is saying, hey, I don't care what type this is. I just want a type that makes sense. I could just use auto for this. And you can see that makes the error go away as well. Strangely, if I use auto for this, I might get a different issue showing up. Yeah, so it's interesting what's happened here. On line 7, when I say auto IDXL, it gives IDXL a type that makes sense given the value that I've provided, 0. The problem is 0 is an int, not an unsigned int, a regular int. So it thinks the type of IDXL is supposed to be int, which of course isn't what I want. There are a couple of ways I can get around that. One of them is just saying unsigned int like I had. The other one is I could do this. I could add the letter u after the constant. When you have an integer constant and you put the letter u after it, you're telling the compiler, I want this to be treated as an unsigned value. And we can see that makes it go away. Usually when I see this, u is uppercase, but it doesn't have to be, as you can see. So I could do this. I'll add, just as a personal preference, I hate this. I really don't like this. For some reason, this notation really irritates me. I don't mind using u, the u specifier, elsewhere, but if I'm making a variable, just make it of type unsigned int. It doesn't make anybody's life easier to put a u there and have the viewer, like whoever reads the code, stare at it and figure out what you mean. Okay, there's me ranting about that. So for the sake of this example, I'll just leave it like this. Now, remove character. So here what I want to do is, I guess I want to delete all occurrences of a specific character from the string. It doesn't say to do it in place. If it did say to do it in place, we'd have to defer the exercise for about 2 weeks because we don't yet know of the feature that we'd need to use. But it doesn't. Instead, it just says that when you're done, this variable that was passed in has to contain the new string. So what I'm going to do is make up a new string. So I'll just say std string s2. And then I'm just going to go through my original string. So for auto C, I don't like the name of the argument because it's very vague. I'm going to change it to remove ch which is technically a little bit of a foul because I've been told to implement this function with this signature. But yeah, calling it ch is going to make it confusing to undo. It'll make it hard for you to understand the exercise in some cases. I want to avoid that. So for every character c in my original string str, what I'm going to do is just add it to my new string. So if c is not equal to remove ch, then I'm going to add it to my new string. So s2 plus equals c. That's it. And then I'll just, at the end, I'll say str equals s2. I'll just take my new string and copy it back into the string that was provided. So we'll try that. Looks like it works. And then we'll enter hello world. I'm going to remove the letter O. And we can see it gets rid of that. Let's try, we'll just do hello world again. And I'll remove the letter L. Looks like that works too. Let's try removing the first letter. Hello world. Remove the letter uppercase H. Now, I've also, in doing this, tested a couple of different lengths of string because I tested one with no spaces. So let's do at least one more where I'm going to try and remove the spaces. So I've got a string there with 2 spaces. I'm going to enter the space character as a character to remove. And oh yeah, that's right, it won't work. So this isn't my fault, it's ChatGPT's testing code. What's happening here is I'm entering spaces, but it doesn't read because I've used cin to read the character that I want to remove. And cin skips over white space, so it won't let me remove a space because I can't type in a space, it just ignores it. Okay, so, well, fair enough. That's not a bug in my code, that's a bug in the testing code, I guess. Let's try, what am I going to pick instead? instead. I'm going to remove the letter A, I guess. Okay, so it's removed A. Yeah, whatever. Let's do one more example. Let's try raspberry, and I'll remove the letter lowercase r, and that looks like it works. Okay, so I think I've now fully tested these exercises, these extra exercises we asked for because the first few were a little bit short, and now we've got a bunch of practice writing functions that take references as their arguments.